This video is a continuation of the first part of chapter 3. So this is the second part. So it says here, moment of a couple. So two forces, F and F prime, such as this, having the same magnitude, parallel lines of action, and opposite sense are said to form a couple or moment. So couple daw niya siya, kaning force, o kaning force. So it tends to rotate the structure kung siya i-apply sa structure or rigid body in a counterclockwise direction. So moment of a couple. So what's the moment of this couple? So say for example this couple is located in this part of the XY coordinate axis. So the moment of the couple F and negative F is this value, or we need to get R sub A, or the distance from O. So say we get the moment, vector moment at point O. So based on the, in this case, based on point O. Okay, so again, moment is equal to R times F, or vector moment is vector R times vector F, where R is the distance from the point at which you will get the moment, or where you will get the moment. So we have RA times, or the cross product of RA times vector F plus RB times negative vector F. Or to simplify this equation, RA minus RB times F, or R times F, or its scalar value, or the magnitude of this vector, is R, or the distance between the two forces. So this value of R times the magnitude of F times sine of the included angle, or simply force times its perpendicular distance. Or if you have two forces, F negative F, this distance is the perpendicular distance between these two forces. So the magnitude of force F times perpendicular distance. Okay, this one right here should be not the moment vector, but this is vector R. Vector R of the couple is independent of the choice of the origin of the coordinate axis. Ano siya? This vector R, independent na siya of the choice of the origin of the coordinate axis, or say in this case point O. So then vector or moment of a couple moment of a couple M, or M sub O, is a free vector that can be applied at any point that will create the same effect. So, kani siya, kung bisag asa ba ni siya na-locate, say na-locate siya dira, tapos i-base nimo siya at say at this point, O prime, dili sa O, still it will create the same effect on such rigid body kung ahan mo siya di-apply. Because the moment M of a couple is a free vector, so pwede siya i-apply at any point with the same effect. Two couples will have equal moments if kanina siya, kaning duha, may be equal if the two couples lie in parallel planes. Parallel planes. So, na siya, say for example, in XY plane or XZ plane, same plane, kung aha sila nag-lie, or parallel ilang planes, then the two couples have the same sense or the tendency to cause rotation in the same direction. Say for example, this one. Kining couple will tend to rotate or will cause a rotation on the rigid body in that direction. Kani din siya will cause a rotation on the body na direction. So, kaning duha, same iyahang tendency to cause rotation, same direction. Tapos they lie in parallel planes, so these two are equal moments. So, muna siya ang one application for moment of a couple. So, nakay duha ka force na siya perpendicular distance between two forces. So, a steering wheel offers an example of a couple in which two parallel forces are separated by a distance to produce torque or moment. So, equals to two parallel forces times distance. So, how do we add couples or moments? Consider two intersecting planes, P1 and P2. So, nalatay plane P1 o plane P2 with each containing a couple. Kay diri sa plane P1 naatay F1 ug negative F1, kini siya is one couple which will tend to rotate the rigid body in that direction. Kanidayon na plane, there exists a couple pod which is F2 na mag-rotate sa rigid body in that direction. Okay, so in order to get the moment, there is a plane 1 moment of F1. So F1 times the distance or distance R times F1. Sa plane 2 pod, R times F2. Resultants of vectors also form a couple. Kung tanaw na to, at this point, natay vector F1 and vector F2. Kani siya is the resultant kung i-add mo ang F1 ug F2. Diri pod, resultant ni siya kung i-add mo ang negative F1 ug negative F2. So, kaning R ug negative R also forms a couple which is equal to R times capital R, or the resultant, the distance between the two forces or two resultants. There's R, or R is F1 plus F2. Okay, by Brignon's theorem, kung ato na siya i-distribute, meron na siya R times F1 plus R times F2, or addition of two couples equals to the resultant couple or moment. So the sum of two couples is also a couple for this one that is equal to the vector sum of the two couples. So vector sum of two couples, or m1 plus m2 equals vector m, or resultant couple. Can be represented by vectors. Couples can be represented by vectors. So, okay, this couple can be represented by a vector with a magnitude and direction equal to the moment of the couple. Okay, so na siya yung magnitude, yung direction, kung aha siya mag-rotate, equal siya sa, or this value, moment of the couple. Couple vectors obey the law of addition of vectors. Couple vectors are free vectors. Again, point of application is not significant. So, kung kanya siya, equal na siya ang nga moment with this direction. Pwede na ito na siya i-apply diri sa point O. Pwede na ito siya i-transfer. Kay nila free vectors, walay significance kung ahad mo siya i-apply or ang point of application niya. So, pwede na ito na siya butang at point O. So, may yung vector moment equal ani. And to get the components, so pwede na makuha mx, my, and mz, or the vector components, component vectors of the couple. Resolution of a force into a force at O and a couple. So, kung kanina siya, kanina force atong i-resolve into a force and couple, pero instead of its point of application at point A, ito siya transfer diri sa point O. So, we can do that by, ang inipot diri is to add equal and opposite forces at point O, equal ani nga force. So, kung tanaw na to, mag-cancel out na silang duha. So, wala siya actually effect. Attaching equal and opposite force vectors at point O produces no net effect on the body. So, wala siya effect on the body. Kung say effect na cause ani nga force due to this force, still the same siya gyapon siya. Cancel out siya. But if you add these two equal and opposite forces, kung tanaw na to, kani siya nga force, kani siya nga force will now be a couple na ang iyahang direction sa rotation is paana ang direction. So, naa na tayo couple of force at point O. So, pwede na ito na siya i-resolve into a force. Kanina force, muna siya nga force. Kanina yun siya nga moment is kani o kani muna siya nga moment. So, instead of a force acting at this distance, at point A, ato siya nahimong system of a force and a couple acting at point O. So, the three forces, kaning tulo, may be replaced by an equivalent force vector and couple vector. So, force and couple, or this is called a force couple system. Okay, so let's go to example problem number 1. Determine the components of a single couple equivalent to the couples shown. So, dire, sa po itong figure, unsa daw ang iyahang unsay components sa isa lang ka couple na equivalent ani. So, i-reduce na to siya into a single couple. Okay, so naay gihatag diri nga duha ka method. Duha ka method kung unsaon siya pag-solve. Okay. So first method, so ganito siya pag-solve. First method is to attach duha ka equivalent forces up this point. Kung ato siya tanaw na to nga system of forces, it is siyang 300 pounds. Wait. So coordinate axis say this one is x. Na itong y, kani siya 3s. The z-axis. Okay. Again, kaning 300 pound force is one couple. Isa na siya ka-couple nga will rotate this rigid body pa nga direction. Again, use right hand rule para ito malibog sa mayroong right hand. So, unsa man siya ang kung gamitan mo yung right hand, kaning 300 pound force mag-rotate siya pa nga direction. So, aha siya nga axis na aha niya i-rotate ang kaning rigid body or aha nga axis. Diba, kung apply mo siya o kaning couple, mag-rotate na siya about x-axis or kaning imuhang tibuok rigid body, iyahang i-rotate about this axis, about x. So, muna siya effect. Aning 300 pound nga couple. Kaning 20 pounds o 20 pounds, wala siya pair nga force para ma-create siya og couple. So, ang first na solution is to add two forces, opposite, equal forces. So, this is 20 pounds and 20 pounds. Same magnitude, pero opposite iyahang direction. So, pwede rin na siya mag-cancel out. Or, kung tanawin mo ang assembly, wala siya effect on the rigid body. But, adding these two will create two more couples. So, kanya siya, na siya pair na kanina nga force. So, isa na lang siya ka-couple. Isa na natin kaduha nga couple. Kanina yun siya nga force. O kanina force is another couple. So, na natay tulo ka couples, tulo ka system, tulo ka couples in this assembly. Okay. So, kani, iyahang i-rotate imong structure pa nga direction. Or mag-rotate siya about y-axis o iyang tuyokon, imong structure about, y-axis. Kani po, kani, iyang intend to rotate imong structure pa nga direction about this axis. Again, para makabalo mo ahang axis siya mag-rotate, use your right hand. So, kani, gamitin mo siya right hand rule. Gamitin mo yung fingers para mo siya i-curl kung aha para ma-determine mo siya ahang axis siya rotate. This thumb, diha mag-point kung ahang axis. Then, kaya din siya kung aha iyang rotation. Okay, so for the first method, so muna siya na natay i-add na two opposite forces but of equal magnitude. So, say muna ito ibutang moment, first moment 1. Say M1 is equal to R times F. Unit is pound, inch, liter. So, distance, perpendicular distance between the two forces times magnitude of the force. So this is equal to kani ato unahon kaning 30. Distance between these two is equal to pila may distance 18. Okay. 4 pwede na tang diretso force times perpendicular distance pwede na po. Okay, diretso na to inani. So diretso na to inani solve. Force na to is 30 pounds times 18 inches. Pero tanaw na to ang signs. Kung kanya siya, again, right hand. Yung right hand. So, nag-ana na siya. Okay, use your right hand to determine kung unsa iyahang signs. Sign aning 30 pounds. Kaning 30 pounds, kung tanaw na to, right hand rule, mag-rotate siya about x-axis. But your thumb is pointing padulong to divide mo thumb. So, muna siya nga about this axis siya mag-rotate, pero ibang thumb is pointing this way, ibang fingers ga-curl siya pana. So, diba, for x-axis, pag padulong dito, positive, padulong dito, bigas, negative. So, your thumb is pointing this way, your fingers ga-curl siya pana, kung kanimong i-analyze nga couple. So, always use right hand rule. So, kani siya karon is negative 30 pounds. Equals. So, pila yung value? 30 times 18 negative 540 pound inch. So, muna siya itong first couple. Okay, M2. Force times perpendicular distance. Say, kani itong M2. Say, kani siya. So, it will tend to rotate the rigid body in this direction about y-axis. Use your right hand. Kung gamitan namin yung right hand, kani nga force. So, imuhang thumb is pointing upwards. Your fingers ga-curl siya paano ang direction? Upwards, meaning positive. So, positive 20 pounds times perpendicular distance between these two forces. Yung perpendicular distance is 12 inches is equal to 240 pound. Why is this big? Pound inch. 240. So, meron siya itong M2. Last couple, M3. Force perpendicular distance equals. So, ang last force na to is gani siya o gani. Again, use your right hand. So, kung gamitin mo right hand, say mo ni imuhang couple or moment. Your thumb is pointing towards you. So, kung nag-rotate na siya about z-axis, kung ang sa z-axis kani, pag nag-point siya towards sa imo that is positive. But if it will point away from you, wala siyang negative yung value. So, in this case, using your right hand, imong thumb, nag-point pa dun sa imo dayon mag-rotate imuhang or kaninga couple will rotate the rigid body in this direction. So, muna yung curl sa imong fingers. And this is your thumb pointing at you. So, muna siyang positive 20 pounds times the perpendicular distance between these two forces, which is equal to 9 inches. M3 therefore is equal to 20 times 9 or 180 pound inch. Okay, so therefore the single couple M sub R na lang, or the resultant moment or resultant couple is equal to kaning M1 M1 again, M1 is kani siya nag-rotate siya about x-axis, so kani siya yahang unit vector. Ang M2 kani itong gibutang M2 nag-rotate siya about y-axis, so kani siya is J. Tapos M3 K kaya nag-rotate siya about z-axis, so paano ihang rotation. So the single couple is negative 540i plus 240j plus 180k. Unit is pound inch. So, siyang answer. So, instead of this system of forces or couples, na-reduce lang siya, instead of tulo ka couples, na-reduce lang siya into a single couple with components along x, y, and z axis. So, yun na siya solve. Wala siya first method. Second method, is to method. So, kung muna itong figure, okay, the second method is mag-sum up daw tag to sum up tanan forces, which is equal to R times F at a point nga atong i-select, which is equal to the moment dayon at that point, or vector moment at that point. So, we need to select a point kung ahata magkuha og moment, or at sa ana nga point ato i-rotate tanan forces. Say kani siya, pwede ta mag-select ani nga point. We can select point A, point D, point E, or point B. So, muna siya ang mga points kung ahata makapili na to i-rotate ang mga forces. Say for example kani siya, so kani nga force, i-rotate na to ani. Pero kani nga force, wala na siya appeal. So, mahimo siyang or ma-cancel out na siya nga force because wala siya perpendicular distance. Padulong ani nga point. kung dili po ta nga point, tanan mong ipa-rotate. Kung dili ta nga point, mawala ning duha. So, ma-eliminate ning duha ka forces. Ang ato ipa-rotate is kanilang nga kaniyang distance along z-axis. Another force na iyang distance is kani siya along y-axis. Then, kanina 30 pounds naman iyang distance along y. So, natay duha ma-eliminate. Kung dili ta nga point, ma-eliminate ning isa, ma-rotate natin na sila tulo. Di lang siya tulo. Kani, na siya kani nga distance. Kani siya, na siya distance along y o along x. Kani pod, na siya distance along y along y lang. Kung dinhi, parihara siya kung sa point A, tanan ay mo ipa-rotate. So, ang pinaka-best point to select, pinaka-best point, kung mag-select gali ka, kung mag-submission ka o moment, mangita ka og point nga daghan kag ma-eliminate ng mga forces. Zero siya. Kung ma-eliminate mo siya, kaya wala na siya perpendicular distance kung mo siya ipa-rotate about that point. So, in this case, dito sa D. Kaya ang mabili na lang is kani, nga ipa-rotate na ito diri yung point. So, summation of moment at point D is equal to R times F. This is equal to moment at point D. So, kung aha ka magkuha og moment or aha ni mo ipa-rotate imong mga forces, adulong ato nga point, muna siya iyahang moment at that particular point. So, muna siya moment at D. Okay, so moment at D, therefore, is equal to, again, R times F. So, unahan na ito ni 30. Dili ta mag-moment, magkuha og moment. So, ato na siyang, basta ahang mga point, magkuha og moment, hindi mo na siyang assume, ma-fix na siya. Kanina structure, fix at this point. Meaning, kaning mga forces can freely rotate, fix, instead nga ito na ito or kanina fix. Ito na siyang i-transfer at that point na ata magkuha og moment. So, fix siya at this point. Ang ato ada yung rigid body may be rotated by these two forces freely. So, kani siya yung i-rotate yung mga rigid body in that direction. So, kung unahan na ito nga force, kanina force, iyahang distance. Again, remember, R is the distance from the point kung aha ka mag-moment padulong sa force nga imuhang gipa-rotate at that point. So, muna siya ang R RCD, R of C with respect to the point kung aha ka na moment siya. So, kana nga R, again, R is gikan diri padulong diha along y-axis, pasaka, so positive. Along y-axis, meaning iyahang vector is J, so positive 18 J times force nga 30 pounds. Ang 30 pounds, padulong dito, naa siya along z-axis. Naa siya along z-axis, tapos siyahang sense is towards dito, which is negative 30 along z-axis. This is K plus another force is kaning 20 Again, iparotate na to siya diri. Na siya duha ka distance. Padulong diri. Diba mo anak pa siya, anak. So, iyang isa ka distance, unahan to isa. So, padulong siya diri, si kani nga distance. Perpendicular distance, ani nga force, padulong ani nga point. Muna iyang first nga distance. Ang iyang ikaduha nga distance is ikan diri. Padulong diri nga point, is kani nga distance. Along y. Along y, kani nga distance, along z-axis. So, plus, okay, unahan na ito na isa. Kaning 20, gikan diri, along, kani siya, muna nga r, 12, gikan diri nga point, padulong dito. Kung along z-axis na siya, that is negative, kay gikan diri, padulong dito na siya. Nag-point siya to, away from, the point kung aha ka makuha og moment. So, negative 12 along z-axis. So, this is k times force nga 20 pounds. Kung tanaw na to ang 20 pounds, nasa along x-axis. So, 20 tagong dito, this is negative minus 20 along x. So, this is I. Last na force nga ang iyahang perpendicular distance from point D is kani nga distance. Same force, pero kani nga distance, which is 9. Pasaka along y-axis. So, positive 9g times. Same naman yapon na siya ang force. Negative because padulong siya sa left side sa imuhang x-axis. So, minus 20 by m sub t, or the moment about d axis, is equal to 18 times 30 i. Okay. IJK. So, remember mo itong IJK. IJK. Pagpana nga direction, positive. G times K, J times K is positive I. So, 18 times 30 positive I. Pero negative na siya. Positive ang J times K, pero 18 times negative 30 is negative. So, negative 540 I. Sunod. Ano siya? K times I. Negative 12 times negative. K times I, positive J. Tapos, 12 times 20, negative times negative equals positive. So, plus 240 G. Dayon, J times I, J, so opposite yung direction, J times I equals negative K. So, negative K. 9 times 20 is 180. 9 times negative is negative 180 times negative K. So, positive 180 K. Unit is pound inch. So, muna siya ang second method in solving for the single couple that will replace this system of forces or system of couples. Pareha siya dito. Okay, na siya solution. So you can check. So first and second solution siya. Another example. Example problem number 2. For the beam loaded as shown, so muna yung load, i-reduce daw na to siya into a system of forces. Reduce this system of forces. Muna siya ng forces. Pero kung beam na siya, lang siya supports. Kani siya. Pero later pa na to na siya discuss about sa iyang support. Sa ani nga example is wala niya ki-appeal ang support ug analyze. Kaning forces lang ang iyang gi-appeal. So, neglecting the effect of the reactions the support unsa iyang equivalent force couple system at A. So, yung first question. Second is equivalent force couple system at B. And then, a single force or resultant. So, yun tulo. Nagipangita. Okay, letter A. Unsa daw ang force couple system at A. So, instead of upat ka forces, muna to siyang isa ka force o isa ka couple located at point A. Or, summation of moment at A equals M at A. And summation of forces equals the resultant force nga i-apply na to at point A. Okay, na to siya. Summation of forces. Summation of forces. So, i-add na to tanan forces equals tanan forces is vertical or nag-act siya along y-axis or yung unit vector is J. So, pataas, positive, paubos, negative. So, positive 150 plus minus 600 plus 100 minus 250 or resultant force is equal to 600 plus 100 minus 250 negative 600 newtons. Next, summation of moment at point A. So, magkuha tayo moment at this point. So, tanan forces, again, kung tanaw na to, kung dito magkuha og moment, kani siya, ma-eliminate. Wala man siya perpendicular distance, patulo kanina point. Two-dimension naman siya, so, pwede rin na to, summation of moment at A, vector MA, ito makuha, force times perpendicular distance, magnitude sa moment. Atong ma-solve, dayon, force times perpendicular distance. Again, gamitan gapan siya right hand rule. So, para makabalota nga negative ba na iyang moment or positive sa kada force. So, again, right hand rule. So, gamitan ito. So, say, dito mag-start. Pa-rotate na to sa A, kaning tulo. So una, using your right hand, i-point nimo imong thumb diri sa A. Diri ang thumb. Kani din siya mag-curl imuhang fingers. So kaning 600, ang thumb nimo is pointing towards point A. Then mag-rotate din siya ang 600 pana. Kung padulong gali sa A, meaning padulong dito sa palikod sa A, meaning negative na siya. Or siya na siya along kuan na siya. This is x-axis, this is y-axis. Kani din siya along z-axis. Padulong sa imuha. So, if your thumb is pointing towards A, then mo din iyang rotation dahil sa 600, so towards A, meaning ang imong thumb padulong dito sa likod ani. That is negative 600 times perpendicular distance niya nga 1.6 meters. 600 newtons, 1.6. Sunod. Again, your right hand rule, dire imong thumb, kung at rotate na to ning 100 pa na nga direction, imong thumb is pointing towards you. So pag nag-point siya towards you, that is positive. Mo din ang direction sa imong fingers nga curl. So mara siya ang right hand rule ha. So pag pointing towards you at point A, kani 100 is positive. So plus 100 newtons times perpendicular distance sa 100 padulong sa point A is kani nga distance equal to 2.8 plus last force na to i-rotate at A. Again, paana siya, imong thumb will point padulong sa A towards point A, so negative 250 newtons times 4.8 meters. Therefore, moment above point A is equal to 600 plus minus 4.8 negative 1880 Newton meters. Or kung i-sketch na to siya, so muna ito ang beam. This is point A, point B. So nato rin nag-act ang ato ang force na 600 Newton. Tapos negative 1880. Again, right hand rule. So ang imong thumb is pointing at point A towards point A, tapos yung moment. Ano siya? So this is negative 1880. So that is the force coupled system at point A. Instead of having 4 forces, kaning upat na forces, na-reduce na to siya into a single force and a couple located at point A. Letter B na question, ipangayo is same force couple pero at point B. So, sa B na sa daw siya. So, same lang yapon. Pa-rotate na to tanan forces, pero this time, dili na to siya ipa-rotate sa point B. So, summation of forces equals the resultant force equals the same 600 newtons along y-axis or J. Tapos, summation of moment at B equals M sub B force times perpendicular distance, or this is equal to M sub B is equal to, so again, iparotate na to siya. Use your right hand. Kaning 100, iparotate na to sa B. So, imong thumb will point towards B. Ayun, imong fingers will curl clockwise direction. So, imong thumb, padulong dito, padulong ani nga point. Meaning, negative 100 times perpendicular distance. Ang 600, kani siya, mag-rotate siya sa imong beam pa na direction, pero imong thumb ani dayon mag-point towards U. So, this is positive 600 times 3.2. Tapos, last force is 150. Padulong dito. Again, your thumb is pointing towards point B, negative 150 times 4.8, or M sub B is equal to negative plus 600 times 2 minus 150 times positive. Ang answer is positive 1,000 Newton meter. Along z-axis, okay. Okay. Okay, sketch na to na siya. So, muna itong beam. At point B, point A, at point B natin ato ang 600 newtons, paubos, negative. Dayon, positive 1,000 Newton meter. So, that is the force couple system at point B. Again, instead of the 4 forces given in the problem. Letter C is unsa daw ang single force or resultant. Single force or resultant that will replace aning upat. So, nakuha naman natin yung value. Kabuluta that if we sum up forces along y equals na siya sa resultant, for this is equal to negative 600. Kabuluta nga negative 600 newtons, but then wala ta kabalo aha iyang location along the beam. So, i-sketch na to ang beam. Si 600 newtons na siya. Pero wala ta kabalo at what point siya mag-act on the beam, say X. Then we know nga natay moment diri. Moment MA. Kanipod ito moment MB. We can get, para masolve natin ni si X. Para masolve natin ni si X, pwede tayo mag-moment at A or moment at B. Point A, point B. Depende sa inyo kung ahaon ninyo kuha ng moment. You can try. Solve ninyo moment at B. Akong isolve moment at A. So, summation moment at A equal to 0. No. Summation moment at A equals to moment at A, where moment at A is equal to force times perpendicular distance. We know that moment at A is negative 1880. So negative 1880 equals 600. Kung makuha kag moment at point A, kaning 600 will rotate paana na direction. Your thumb is pointing padulong sa point A, towards point A. So negative 600 times iyang perpendicular distance na x, or x is equal to 1880 divide 600 is 3.133 meters. So, muna siya ang location of the 600 Newton force on the beam. So, location ani. So, instead of a path, ato siyang na-reduce into resultant lang, isa lang ka force na mag-act at x equals 3.133. Try again. Siya solution dari. So, pwede nyo i-check kung yun saan nyo pag-solve. Pero wala na ako nabutang dari. Ang letter C na solution. Letter B lang siya. Ang tabuan. Sample problem number 3. So, muna ito ang system of forces. So, yung diri, na daw tulo ka cables attached to the bracket. Asyon, itong bracket. 3 cables, 1,000, 1,200, o 700 newtons, located at B, C, and D are attached to the brackets. Replace the forces with an equivalent force coupled system at point A. Hindi siya ito kailangan i-solve. Instead of these 3 forces located at different points in the bracket, ato daw siya i-resolve into a force of couple at point A. Dire. Okay, so let's solve. So, ang kailangan nato is to get the resultant force, say F, R, na nasa A. F, R na lang. And moment, resultant moment at point A, where Fr is equal to the summation of tanan forces, which is equal to, i-add na to ang force at C plus force at D plus force at B. Force BE day. BE. Kay force with 2 known points mo siyang BE. Given 2 points on its line of action, nga diya nag-act ang force BE. Tapos, to get the moment, resultant moment at A, is we need to sum up R times F. Vector R times vector F. Sa mga vector R. For this force at point C, again, R is gikan sa point kung aha ka magkuha og moment padulong sa force. So this is R of C with respect to A. Kani siya is R of B with respect to A. Kani din siya, nawala si D. R of C with respect to R of D with respect to A. So this is point D. Okay, so mahimo na siya ang R C with respect to A times FC plus R of D with respect to A times vector force D plus R of B with respect to A times F vector FB. So, nana din tayo moment o force. So, instead, aning tulo, mahimo na lang siyang isa ka force, resultant force, o resultant moment located at point A. Okay, so unang to solve is kaning forces time kaning mga R. Kung nanata ni forces, masolve na ito si resultant. Kuhaon din nato ang mga R, i-multiply nato sa nakuha nato ang mga forces, sira. Kuha din nato si moment. Okay, so una ni, what is F sub C? Vector force at point C is equal to, ano na to ang force at C? Ano siya ang force at C? Na siya duha ka components. Yung isa ka component is along X. Yung isa ka component is along Z axis. So, ibutang na to. Na siya F, C, X, and F, C, along Z axis. Or this is equal to 1,000 cosine 45x or I, yung unit vector, positive kay to the right. So, muna siyang positive. Kadili siya, padulong dito. So, negative F, C, Z minus cosine 45 unit vector K along Z axis. Unit is in newtons. Or ito na siya i-simplify, 1,000 cosine 45 FC is equal to 707 K Newton. So, Newton F sub C. Next, solve for F vector FD. Again, na siya component FDX and another component dy along y-axis. Ang fdx is positive kay to the right 1,200 cosine 60 I plus positive yang y component kay upwards 1,200 cosine 30 j or fd vector fd 12 cosine 60 600 I plus cosine 30 1039.23. This is F sub B. F BE. Okay, kaning force. This is F BE from point B to point E. So, that's yung mga coordinates. Dili siya parehan nga given lang ang angle tas located at that point. In this case, natay given two points kung aha dapit ang line of action sa FBE. So, ang formula ni is magnitude times unit vector BE. Magnitude sa FBE is 700 newtons times unit vector. So, distance between point B and point E along x-axis. Ang point B along x is kani nga distance 75. Gikan dire. Ang kanida yon na siya'y coordinate x, yung coordinate sa y o z. Kani yung x. So 150 mm kani nga point gikan dire sa point O. Na 150 na siya. Kung 150 na siya, padulong dire is 75. So gikan sa B padulong sa E is 150 minus 75 or 75. Dayon, yung distance is gikan dire paana man siya along x. So positive 75 I. Distance sa B ug sa E along y-axis paana. Yung coordinate along y is negative 50. From B padulong diri sa O, kana siya nga distance is 100 mm. Gikan diri sa point O paubos mo ni siyang negative 150. So gikan sa B padulong diri sa E mo ni siyang 100 ug negative 150. So kaning tibuok distance is 150 downward, so negative 150 J. Then last is along z-axis. Yung coordinate along z is 100. So gikan sa B padulong sa E, gikan sa A point O diri sa center padulong diri, that is 100. Pero from the center padulong sa B is 50. Kung 50 na siya, 100 minus 50 gikan sa B padulong sa E is 50. Dayon iyahang direction is padulong man diri sa towards you, pointing towards you. Yung distance from B to E paana nga distance. Therefore, this is positive 50 dayon over d na square root of 75 squared, 150 squared, 50 squared, 175 for force, vector force BE is equal to 700 times 75 divided by 175. 300 I minus 600 J plus 200 K meters. Okay, so therefore, FR, or the resultant force, at point A na dayon siya na ito ibutang, is equal to, i-add na to tanan I, o ganun I, plus 600 plus 300, 1607, 107, I, sunod tanan J, 1039, og negative 3 minus 600 plus 23 J K dayon is gonna minus plus 200 507 minus so this is the resultant force at point A. So kano siya to check lang the solution. 507 4916 1607 49 507. So correct ito nakuha nga values. Okay, so dali na din ta. Solve for, so what is the moment, resultant moment at point A? R summation of R times F. So una na to kuha ang R C. Okay, na din tayo R D A o R B with respect to A. Ang RCA, tara, ano siyang RCA? So na siya distance along Z ug along X. So ang RCA na siya X distance nga 75 positive to the right ug negative nga 50 along Z-axis. So plus 75 I minus 50 K. Unit is millimeters. Again, ano siya itong RCA? Na siya side, na siya doha ka side, or kung ano siya hypotenuse. So na siya distance along x-axis, na po siya distance along z-axis. Along x, positive, kaya padulong sa right, yung positive 75 ay along z-axis, padulong dito sa likod, so negative 50. Sunod, ano sa tawag sunod? D. R D sub A is kaning distance. From point A to point D, kung tanong ito siya nakaalam na siya. So, kaning distance, na siya coordinate along Y, o na siya coordinate along X. Yung X na distance is, ilang ni? From A to D, kaning distance is 100. Positive 100. Dayon ang iyahang distance along Y, paubos, negative 100. So, positive 100i minus 100j. Tapos, RB sub A. Ganun siya. Dili pwede bali ha. Ay, anak, imong R. No, that is wrong. Dapat, ang R should start at the point kung aha ka makuha og moment padulong sa point of application sa force. So, always remember that. So, RB sub A, na siya coordinate or na siya distance along X o along Z. Along Z, positive. Along X, again, positive. Positive 75i plus 50k. So, C with respect to A. Moment sa C with respect to A, this is equal to R CA. So, vector R CA times vector FC. This is equal to 75i minus 50k M times F sub C is so kani siya times ani. Masolve nato ni siya using basket method. Or this is equal to, so sa basket method, I, J, K, I 75 R times F. So R in unay butang. Along Y is 0. Along Z is negative 50. Tapos 707.107 0 with negative 707. Okay. Downward, diba positive? Positive. Pero yung value is 0. Sunod, kana nga value, which is equal to negative 50 times 707 point. Negative 35355.35 G. Tapos, K times 75 times 0 equals 0. Sunod, pasaka, negative. So, kung siya, dapat negative 0. Gani, again is 0. And then last is negative minus negative 75 times 707.53033 J or M C with respect to A 25355.35 plus 23033.5 17677 point. This is Newton millimeter. Sunod, M of D, D with respect to A, RD, vector RDA times F sub D is equal to 100I minus 100J times again using basket method. I, J, K 100 negative 100 0 600 10 39 0 0 positive downward 0 1 2 3 K minus pasaka negative 60 negative K 0 0 or M D relative to A with respect to A 103.103.923 plus 16 K Newton mm. Then lastly, M B relative to A is equal to R B relative to A times F B 75 I 50K times Okay, again, using basket method, ini siyang I, J, K, 75, 0, positive 50, 300, negative 600, positive 200 equals 0, 50, positive 15, J, 5 times 600, minus K, minus pasaka negative 0, negative 30, I, tapos 200 times 7, 15, positive 15, positive times negative, siya negative 15, so cancel out. Ang mabilin is equal to third positive I minus K, 45,000 Newton mm. So this is MB with respect to A. Therefore, resultant with respect to A is equal to, again, sum up na to tanan I, tanan J, ug tanan K. So, wait. Ano siya is J, K. So, 30 I plus J. Tapos, ang K is 163 minus 118 plus 118 923 okay, Newton. So, itong final answer. So, this is the resultant moment for the single couple at A and the single force FR at A. So, instead na kayong tulo, sunod na ta diri resultant force FR o MR with respect to A. Una niya ang coordinates sa resultant o components not coordinates, components of the resultant force, components of the resultant couple. So we can check kung correct na ito answer. 30, 17.6, 118.9 niya is Newton meter. 30, 17, 118. Okay, so that's it for chapter 3. So, saan pag-resolve of system of forces into a force lang, into a force couple, force o couple, such as this one. An example. Ayun sa patutong pang solve. More to siya. Okay, so if you have any questions, just message sa itong group chat so that we can answer your questions. Okay, so pwede niyo review dire yung solution. Okay, so that's it for chapter 3.